what would be the x-intercept on this graph? The x-intercept, what would we call that? What would the number be? I think it's a 3 over there, right, on that x-axis. So that x-intercept is 3, 0. And my question is, what if the x-intercept was even over here or over here? What's the y value anytime you're crossing the x-axis? The y is always 0. So I'm going to just throw that little fun fact over here. And then for my y-intercept on this graph, what's my y-intercept on this graph? 2. And so what would that point be? 0, 2. What's the x value anytime you're crossing the y-axis? 0, yep. And so that little fun fact does help when we go to graph. If someone says, hey, graph it just using those x and y intercepts, you might be used to getting it into that y equals mx plus b, but you don't have to do it. If I wanted to graph it using the x and y intercepts, I might write myself a note like, oh yeah, for the x-intercept, the y is always 0. And if the y is 0, couldn't I really just go like this? Right? If the y is 0, isn't this really just going to disappear? 2 times 0 is going to get me 0. But if you're like, I wouldn't skip that step, you can always plug in a 0 for y. And then we just go solve for the x. But if anyone, like I grew up, my teacher was always like, put your finger right over it. The y is 0, it's gone. So we're just left with 3x minus 6 is 0. So that's what we'd have once we put in that 0. 3 minus 6 is 0. And then you go solve for the x. So I would add 6 to both sides, and what would we get for my x? 2. Then I'd go to my graph, and I'd go on that x-axis, and I'd go where 2 is, and I'd plot a point. Ficus has very little work shown for the x and y intercepts, and I'm totally good with it. Where you just kind of doing it in your head, Ficus, like cross that out, move that 6 over. Yeah, I'm good with it on this topic. Don't feel like you've got to show all of this if you're like, I'm just seeing it by crossing things out. All good. What about for my y-intercept? You do the similar thing, but now the x is 0. Again, you might just cover it up because that's going to be 0 and be left with 2y minus 6 equals 0. Or you could just plug in the 0 for x. 3 times 0 and 2y minus 6 is 0. So we get 2y minus 6 is 0. What's my y going to be? 3. I'm going to go up to my graph. My y would be 3. You could use a ruler or you could not, but as soon as you connect 2 points, you've got a line. And we would get the same line if we put that into slope-intercept form. Here's slope-intercept form. Does anyone remember y equals, you know it, y equals mx plus b. What's the m stand for? The rate or slope, you got it. And the b? You know it. And the y-intercept is always where we start. It's always where we start a graph if we're graphing from the slope-intercept form. In order for slope-intercept form to work, though, we need to make sure that my y is by itself. Is my y by itself here? Then we're ready. We're going to start at my y-intercept, and we're going to do my rise over run. So we're going to start down 2, and we're going to go up 3 over 4, or down 3 left 4. What happens if my y is not so by itself? Can we get it by itself? Sure. What would we do first? That's so funny. Someone else said subtract 5 in my last class. But if I subtracted 5, wouldn't that bring more to my y side? If I brought my 2x over, right? Because if I subtracted the 5, then I'd have to move the y over and it'd be negative. So we could say y equals negative 2x plus 5. You guys down with that? If I subtracted 2x from both sides to get my y by itself? And I always put the x in front so that it's y equals mx plus b, like it follows that form. Where am I going to start that graph? Thanks. Up 5 on that y-axis. If the slope is negative 2, what's that going to look like? Up, down, left, right. What are we doing? Down 2, right 1. Down 2, right 1. Good job. And then we connect them as straight. Oh, gosh, that's a terrible one. Try that again. There we go. You guys, last one for the day. We're going to finish early. This is good. Oh, whoops. I do have this little slope here. I guess I was just trying to say rise over run if you were to have a little mind lapse. Slope can be that y, rise over run, change a y over change an x, however you like to think of it. And then lastly, does anyone get some telemarketer calls on your cell phone? Oh my gosh, I get so many. Does anyone have silence unknown callers turned on for their phone? Do you guys know that that exists? True facts. In 2018, telemarketing calls were 7.7% of the market. 2025, they're now 25.73%. Gross. And I'm asking, what is the average rate of increase? This is kind of how you described it, Shar. You're like, oh, rate of increase. That's just our slope. That's just changing Y over changing X. Back to these fun facts. How can I put these pieces of info into two different points in order to do like rise over run, which is really just Y minus Y over X minus X? How can I put this info, pink in 2018, 2025, how can I put those as coordinates? Which do you think should be my X, the time, 2018, or the percent? The time. That's always independent. I cannot control the time. In 2018, because if I could, I'd go back to that little girl's math teacher and I would change that class for her. 2018, it was at 7.7%. What's my other coordinate? Thank you. Is 25.73%. And they're saying, how much is this going up every year is what they're wondering. So what would be my change in Y over change in X, guys? X would be 7. He says we got 2025 minus 2018 is 7 on the bottom. Agreed with that, Vic. And on the top, I'm going to do change in Y. So I'm going to have 25.73 minus my 7.7. And you might be like, ooh, did we have to change that into decimals since they're percents? If we leave them percents, our answer will be in a percent and we'll be fine. I will do that for you guys. If we did 25.73 minus my 7.7, we got 18.03 that Ficus said we need to divide by 7. And we're going to get 2.58. And my question is, what would be those units? What were the units that we were dealing with up top? 25.73 and 7.7. What were those units? Percents. And then 2025 and 2018 are years. So what's happening? The percent of telemarketers is going up 2.58% per year. Good job, you guys. Awesome.